Hello guys, today we are going to discuss about signals and systems. Signals and systems is a very fundamental subject to understand the concepts of digital signal processing, speech processing, image processing, and all other communication engineering concepts. Now let us discuss about signals and then about systems. Signals. A signal can be defined in many ways as follows. The first definition says that a single valued function of one or more independent variables such as time, position, pressure, temperature, and so on. The second definition says that any physical quantity that varies with time or any other independent variable. We should try to understand these two definitions with the help of an example. This is a sinusoidal signal always having positive half cycle and negative half cycle during one complete clock cycle. Now, let us describe the shape of the signal. Any signal which is having independent variable on x-axis and the amplitude or value on y-axis. For this sinusoidal signal, the x values are 0, 90, 180, 270, 360. These are independent variable values. The reason that x is called as independent variable means x does not depend on any other variable or any other value, and also the x is not a fixed number. It is always varying throughout the region from minus infinity to infinity. Y means it is an amplitude or the value of a signal. This y will change according to the value of x. That's why we should relate y and x as y equal to sine of x. The reason is this is the sinusoidal signal, so that y equal to the functional representation of an independent variable. That means the function here is sinusoidal, so that sinusoidal shortcut form is sine. Y equal to sine of x. Now we should substitute different values of x. If x equal to 0, then y equal to 0. If x equal to 90, y equal to 1. Equal to 180, then y equal to 0. Equal to 270, then y becomes minus 1. If equal to 360, then y becomes 0 again. We should observe that for each value of x, we have only single value of y. That means single valued function means this sin x is always having only one value, and a single valued function of one or more independent variables. Here in this example only we have taken single independent variable. Sometimes we may take more number of independent variables also. Now according to the independent variables, we have to find the value of the amplitude or value of a signal. This is the first definition. Now here instead of x we can apply time, position, pressure, temperature, and so on, depending on the type of the signal. Suppose, let us take one example. If the time t is an independent variable, then if we take the sinusoidal signal again, then we named it as sine of t, y equal to sine of t. That means y equal to the functional representation of an independent variable time t. Okay, so depending on the type of the independent variable, we should write the functional representation. So for every value of independent variable, we will get only one amplitude value. That's why it is said to be a single valued function. Coming to the second definition, any physical quantity that varies with time or any other independent variable. That means any physical quantity means it should have some numerical value when it varies with time or any other independent variable. That means here now when we change the value of t, we will get the single value on y-axis. That value is defined as a number. Is the second definition of a signal. Now let us come to the examples of signals. These are the examples. Human speech electric current signal, electric voltage signal. These are the some examples of signal. Depending on the number of independent variables used, signals can be divided as follows. The first category is one-dimensional signal. That means if a signal is a function of only one independent variable, the representation is f of x. Examples are music, speech, heartbeat. These are the some examples of one-dimensional signals. Now let us come to this two-dimensional signal. If a signal is a function of two independent variables, the representation is f of xy, function of two independent variables x and y. The example is photograph. Photograph means it requires both width and length. That's why the photograph signal is an example of a two-dimensional signal. Now let us come to the multi-dimensional signal. Multi-dimensional signal means a signal is a function of two or more independent variables. Then we called it as multi-dimensional signal. The representation is f of x, y, z like this. The motion picture of a black and white TV is an example for multi-dimensional signal. Now let us come to the types of signals. Signals can be divided into different categories based on time and amplitude. If the time is continuous, we named it as continuous time signal. If the time is discrete, we named it as discrete time signal. Here, let us see, this is the continuous time signal. That means on x-axis, we should take the independent variable time. If we measure the values for each and every value of time on x-axis, then we named it as continuous time signal. If we measure the values at only discrete values of time, then we named it as discrete time signal. Now let us come to the amplitude based. If the amplitude is continuous, then we named it as analog signal. Let us see the shape of the analog signal. Now we should focus only on amplitude. The amplitude is continuously varying along the y-axis. This is called as analog signal. Now digital signal. If the amplitude is discrete along y-axis, then we named it as digital signal. Now we can see here, this is an example of a digital signal. Along y-axis, we can see between two steps, here we have some gap. The dots which indicates gap between two steps. That means a discontinuity in the amplitude value. That's why this is said to be a digital signal. For analog signals, the amplitude which is always having some real values. Whereas for digital signal, the amplitude which is either having 0 or 1. This is a binary data. Each step which is indicated with the value of 1, the gap is which is indicated with the value 0. That's why the digital signal always indicates with the binary data either 0 or 1. If the amplitude is present, its value is 1. If the amplitude is not present, the value is 0. Now coming to the analog signal, the amplitude value always represented in real values. This is the basic difference between analog signal and digital signal. Now, by combining these time-based and amplitude-based type of signals, we can get 4 combinations of signals. The first combination is continuous time analog signal. The second type is discrete time analog signal. The third type is continuous time digital signal. The fourth one is discrete time digital signal. Now let us come to the systems. The definition of a system is defined in many ways as follows. The first definition says that a physical device that can produce an output or response for the given input. That means the system, it is also called as a physical device which is used to produce the output signal for the given input signal. This is the definition of a system. The definition says that an entity that works on an input signal and transforms it into an output signal. That means the system is any element or any device which works on input signals and which transforms input signals into output signals. Based on this second definition, we should relate input and output as follows. Y of t is output of the system or response of the system, where t is the transformation. X of t is an input signal, also called as excitation. Now, the relation is y of t equal to t of x of t. That means the transformation of x of t, nothing but an output signal. Now, coming to the system, here if we apply the input signals, continuous input signals, then we will get the continuous time output signals. Then we named it as continuous time system. In the same way, if the input signal is a discrete type of the signal, output also in discrete form, and the name of the system is discrete time system. This is a brief introduction about systems. I hope you understand the concepts of signals and systems along with the definitions very clearly in this video. Thank you.